Hi, how's it going? So I'm going with the Martian style of video, which is every day I just upload a little kind of quick update on how the ray tracing is going. So here's where we are. Well, no, this isn't the final thing. One thing I've done is I added plane capabilities. So getting the intersection of a ray and a plane is it's straightforward. It's a well-defined problem. The next step above that is, okay, so we get the intersection of a ray and a plane, but that's kind of an infinite plane. So then the next question is, how do we constrain the plane so that it only has certain dimensions? Okay, so I'm just going to describe this in non-technical terms first of all. The plane that we see here has a normal. That's the direction 90 degrees to it. It's pointing directly up in the z-axis. It also has a tangent. Let's say the tangent is in the x-axis. And then it has a second tangent, a second direction still inside the plane called the bitangent, in this case the y-axis. So we're going to define the plane as a range along any point on the plane is a range along the tangent plus a range along the bitangent. So we'll take the ray first of all and we'll find the point on the plane where the ray intersects with the plane. And then we will project or take the direction vector of that point relative to the center of the plane. So let's say right now I look at this corner here, then that direction vector will be the corner minus the center of the plane. That gives us a direction vector which is inside the plane. Then we project that along the tangent and the bitangent to give the coefficient u and v, describing the point's position within the plane. And then we compare that to some defined ranges on u and v. So if we jump into the shader code, for our plane structure, we have these vectors, and then we have some constraints on like how far along the tangent and how far along the bitangent the point can be within the plane. And this gives us like a piece of a plane. And then the other thing is, if we run this, we'll notice that it looks pretty good for the spheres, but with the plane, the random noise that we add looks kind of horrible. So I'm still kind of working out how to fix that situation. The issue is there needs to be some random noise in the reflections and stuff. Otherwise, the image looks too sterile and bad. I mean, I could remove all of the random noise. It would not look good. But GLSL does not have a random noise function, so we have to kind of approximate it with pseudo-random functions. Typically we apply, like I think the one I'm using in this shader is the classic like take sign of a number scaled up by a really large amount or something. The noise is really dependent on the noise function, which might not be that good. So I changed a few things around. Just close this off. So this is a later version. Instead of taking a noise function, this is the noise function that I was kind of using, by the way. Instead of doing that, I am taking a noise texture. So on the CPU side, I generate a bunch of random numbers using NumPy's random function, and I bake those into a texture and I ship that over. And then I sample from that texture, which kind of improves the noise. And then at the same time, not quite. So if we run this, just takes a second. Okay, so if we've got a plane, well, we can combine planes together to make levels. But there are issues with this, okay? So if we have an arbitrarily large number of planes in our system, then that will just really slow it down, because the math to get the collision on a plane is not as good as the math for a sphere. And also the results don't look so good. So these planes, I mean, I don't know, they look okay. They look okay. So anyway, here's the situation. So what I've done to constrain the number of planes in the scene is I wrote a simple algorithm to take a map and split it into pieces, into rooms. And then I've got these door objects in between. And based on which side of the door I'm on, it only loads in a certain amount of data. But similarly, there are issues here. Let me just think, what are the issues? Well, for one thing, the number of objects that we can pass through in a uniform is limited, and this depends on the device. On the laptop I was developing this on, it was really large. I could pass in 250 of these, no problem. On my graphics card that I'm running it on now, it's really bad. If I go above 32, it'll crash. Now, passing data through in uniforms is okay for a few parameters. It's not so good for large chunks of data. So there are two approaches which could be used here. One approach is similar to the noise. I create an image, a texture, with the pixels storing a bit of data. Like we've got red, green, blue could store the position of a plane. And then I'd set it up so that along the x-axis, every new x pixel is a new sphere, and then every y pixel is a different attribute within the sphere. And I could do that. That's fine. That's great. Another method is to use what's called a shader storage buffer object, SSBO, and that's basically like a vertex buffer, pretty much, that you would have for points, except you can pass in arbitrary data. And if we were working in C, you could even pass in like structs, the same sort of structs that we're using here, and parse that data automatically, which I think is really cool, but we're in Python land, that's okay. Okay, so getting ahead of myself. So there's that. That's an issue. Issue number 2 is that we're starting to run into performance limits. So I think at the moment, this is okay. Actually, this is okay. But I think there's a way I can speed this up. Let's think about it. What's the benefit of ray tracing? Like, let me go... sorry, this is just a little live. Okay, so let's jump all of the rebounds and stuff and just produce the final image, okay? This is kind of the first thing. Before we do any rebounds, this is the first thing that the ray tracer sees. What are we doing here? Of course. I'm getting ahead of myself. I was using the pixel coordinates to sample the random texture and get that random noise for the reflection. Okay, so we look at this. This is a ray tracer. This is a really bad use of a ray tracer, right? Because what is it doing? The spheres, okay? Ray tracing spheres, that's a really good use case because it's a shape which would typically take a lot of triangles, but we can just kind of do it in one pass. But these planes, using the math to get the intersection of a plane and a ray is not a good use of the graphics card. The benefits of ray tracing is reflections, lighting, and shadow. These things all become much easier, much more straightforward in a ray tracing environment. So if I run this, we get, we get all these little bits of detail. Which, again, I'm 50-50 on the noise. I'm not such a big fan of the noise, but there does need to be some sort of noise there just to make the image look a little more natural. I'll have to revisit that. But things like this reflection and stuff is really nice, and that would be a little harder to do in a standard shader. And we've got, if we had lights in the scene, we could trace to the lights and get really nice shadows, I think, at not much extra cost. So what I'm going to investigate after this is I'm going to investigate kind of hybrid rasterized and ray tracing together. So I'll have like deferred shading. I'll have a geometry pass, which takes a rasterized snapshot of everything that the camera can see, and then pass that through to a G buffer, then load in the G buffer as well as a description of the scene to get reflections of the world onto those things that we can see and kind of get the best of both worlds. And then thing number three, and this is just a really minor thing, is there's probably a better system that I can use to divide the map up. Sorry, this is actually rambling. But okay, so this is what I got at the moment. This is a map. But if we look here, okay, so these two pieces are going to have the same material, so they would be joined together. But in this system that I'm using, it would actually break them up into two separate planes. We'd have two planes here. But I made a sector room system, which would, under that system, I'd be able to join them together as one plane, maybe save a bit of performance. But anyway, so those are just my little shower thoughts, basically. And yeah, I hope you found that entertaining. At a future point, this will all be done, and I'll have a proper series on how to ray trace. But for the moment, it's just experiments and research. Have fun, and I'll see you sometime soon. Bye.